A very short clip, I think 3 or 4 slides, nothing much, just to review what we need to remember about proteins before we talk about protein synthesis. So prior to this, we had talked about protein, structural and functional proteins. So I always say that structural proteins are building blocks and functional proteins have jobs, or they're doers. They have things like antibodies and some neurotransmitters and various enzymes. Those are all types of functional proteins. So if we were to look at our body, protein makes up about 50% of all of our organic material in the body, and it has lots of functions. As I said, building blocks, sorry, and protein joins together to make more complex proteins. We have proteins in all of our cells, different kinds of proteins. How they're built together, how they're put together or bound together determines whether its structure or function is their focus. So if we look at structural have an appearance if we look at them now. Remember, this is built in the cell. We can't even see the cell with the naked eye. So you can imagine how small this all is. So structurally are very strand-like, and they bind things together. They have strength, and they're quite stable in terms of proteins. Collagen and keratin are good examples, and those are keratin we find in our hair and nails, and collagen is in our connective tissue. Functional proteins then look different. They are mobile, they're spherical, and those are the ones that are involved in actions in our body, like processes. They're not as stable. They're easily then destroyed. Antibodies, hormones, enzymes, all are examples of functional type proteins. And so what we're doing here is we're talking about the concepts of it, and then as we move through systems, we examine how those particular proteins apply to that system in later systems. So just to highlight about enzymes, they're probably one of the most common functional proteins that we talk about. And remember, we talked a little bit earlier about this, that they promote chemical reactions. They're catalysts. They're biological catalysts. They allow us to do that action, whatever it is, by not using quite as much energy as we might, therefore giving us better increased metabolic reactions. We only use a little bit up, and they can function over and over and over again.